lecture series on computer organization and architecture. We'll discuss lecture number 23 of module number 3. Contents that was covered in the previous lecture are example program for accessing an IO device. So we have discussed when an IO devices are computer system, so how a data transfer is going to take place between processor and an IO device. So we're using an example program, that is with the help of connecting IO device like keyboard and display to the computer system. So how exactly the data transfer takes place, so that is we have discussed regarding the registers associated with the keyboard as well as a display device, as well as in order to every time when the device is ready, let the device might be a keyboard or a display device, so we need to check out the status flag, that is flag has to be checked, called as in flag and out flag. So depending upon the flag status, so it can be either receive the information by the processor or information can be transmitted to the processor. So example program relevant to this concepts was discussed in the previous lecture. Contents that is covered in this lecture are interrupts. So learning outcomes: after this lecture the students will have a better understanding of transferring the data between processor and an IO device. So here in this case, so in that is how the data transfer takes place between processor and an IO device with the help of an interrupt signal. So here in the previous class what we have discussed, that is accessing an IO device, each time whenever a data transfer needs to happen, the processor is going to check out the status flags in and S out. So now we have alternative method. So whenever a device is ready, so rather than checking the status flags in and S out, we can check out an interrupt can be generated. So interrupt here, it is nothing but it is a signal generated by the device, and that signal will be transmitted to the processor indicating whether the device is ready or not. So this is the Bloom's taxonomy pyramid. So here we are going to understand the concepts of an interrupt, interrupt signal, interrupt acknowledgement, interrupt latencies, difference between subroutine as well as interrupt. So as we are going to understand all these concepts, it is going to fall under the taxonomy level number 2. So now we'll discuss regarding interrupts. So in case of program controlled IO, so we know that the processor continuously used to monitor the status of the device, so whether the device is ready or not. So during that time, as it needs to it will be keep on polling the device, so that is it will be monitoring the status of the device. During that time the processor is unable to do any other task, so that is it does not perform any useful task, so their processor time will be wasted. So therefore we have an alternative approach. So whenever the that is till the IO device becomes ready, the processor time can be utilized for executing some other useful task. So therefore an alternative approach is provided. So an alternative approach would be for the IO device to alert the processor as soon as it becomes ready. So that is whenever the IO device becomes ready, it can send an alert signal to the processor indicating that the device is either ready to receive an information or ready to transfer an information, so that whenever till that much of time the processor can perform or it can execute some other useful task rather than wasting the time. So that particular signal which is sent by the IO device in order to alert the processor as soon as an IO device becomes ready, so that particular signal we call it as an interrupt signal. So that is an alternative approach would be for the IO device to alert the processor when it becomes ready. So this can be done, that is it can do so by sending a hardware signal called an interrupt to the processor. So interrupt is nothing but it is a signal sent by the IO device to the processor as soon as an IO device becomes ready. So this signal will be transmitted on the bus, so that is at least one of the bus control lines called an interrupt request line is dedicated for this purpose. So in order to transmit an interrupt signal, so we will be using a bus called as an interrupt request line. So with the help of interrupt request line bus or line, the interrupt signal will be transmitted to the processor. So now the processor can perform other useful tasks rather than waiting for the device to become ready. So that is, when the interrupt signal is received by the processor, then only the further action is going to take place. Else, until it receive the interrupt signal, the processor will be keep on doing certain useful task, or it will be executing some useful programs. So this is the diagram how the program as well as ISR will be executed. So we have program number 1, we have a certain set of instructions. So these set of instructions are available in a program number 1, and we have an ISR. So here in the now we will be discussing regarding interrupt as well as an ISR. So we came to know that what is an interrupt. So interrupt is nothing but it is a signal generated by an IO device when the IO device becomes ready to transmit an information or ready to receive an information. It is an intimation given to the processor. So during that time the processor may be running certain useful task, so or it may be executing certain program. So now let us consider the program number 1 will be executed by the processor. So it will be keep on executing the instruction one after the other. So assume that by the time it reaches the instruction number I, so during that time an interrupt has occurred from the IO device. So that is an interrupt signal will be received by the processor. So now once the interrupt is being generated, so now it has to stop executing the currently running program. So whatever it is executing, whatever the task it is doing, that task has to be stopped. It should not execute that currently running program. It has to stop the currently running program, and it has to provide the service for the generated interrupt. So now therefore whenever an interrupt occurs, the currently running program will be stopped and a service will be given for the generated and the service will be given for the IO device that has generated the interrupt. So that particular service, when an interrupt occurs, whatever the service that is given, we call that service as an interrupt service routine. So here routine is nothing but it is a set of instruction. So whenever an interrupt occurs, certain task has to be implemented. So that task or set of instructions we call it as an routine. So providing a service for the interrupted device, so we will call it as an interrupt service routine. I repeat, what is interrupt service routine? So for the device that generated an interrupt, a service has to be provided. So therefore we will be executing, that is the processor will be executing an ISR. So routine is nothing but it is a set of instruction. So that is, during execution of the ith instruction in the program number 1, an interrupt has occurred. So at the ith instruction itself, the currently running program, whatever the currently running program, currently executed program will be stopped. From that point of time, the service providing the service for the interrupted device will be started. So it is going to execute the certain set of instructions in order to provide the service for the interrupt generated device. Once the service is provided or certain set of instruction is executed, so it should come back to the main program in order to resume the execution. So at ith instruction it has stopped execution. So therefore after executing the ISR program, so execution of the main program has to be resumed. So that is, the execution needs to be started from I+1 instruction. So therefore it is going to resume back the execution of the main program. So this is regarding interrupt as well as ISR. So now processor is executing the instruction located at address I. So when an interrupt occurs, so routine executed in response to an interrupt request is called as an interrupt service routine. So processor is going to execute the instruction loaded at an address I. So during that time an interrupt is going to occur. So therefore, in order to provide the service, so we need to execute a routine or a set of instruction in response to an interrupt request, and that routine we call it as an interrupt service routine. So when an interrupt occurs, so control will be transferred to an ISR. So that is currently running program has to be stopped executing and a new program, that is ISR program, needs to be executed. So once the ISR program has executed, it should come back to the I+1 instruction. So in order to come back to the I+1 instruction, so I+1 instruction address has to be saved. So therefore, so before, when an interrupt occurs, control automatically will be transferred to an ISR. So but before transferring the control, the current content of the program counter, so program counter, we know that it will be always pointing to the address of the next instruction. So that address of the I+1 instruction must be saved in the known location. So this will enable the return from the interrupt instruction to resume an execution at I+1. So that is after execution of an ISR, in order to resume back with the execution of the main program, so it has to execute the main program from the instruction I+1. So once we have saved the content of the program counter as it is saved, so it is easy to come back for the execution, or in order to resume back the execution it becomes easy. So that is where it has stopped, the next instruction will be executed. So that is, this is going to enable the return from the interrupt instruction to resume the execution of the program or resume the execution at an instruction I+1. So return address or the contents of the program counter normally stored on the processor stack. So in most of the processor, so return address of the main program will be stored in the processor stack. So now we'll understand this interrupt concept by considering an example. So now let us consider a task that requires some computation to be performed and the results to be printed on the printer. So there is a certain task to be executed. So and after executing the task, the information needs to be, or result needs to be printed on the printer. So therefore consider two programs. So let the program consisting of two routines. One of the program is called as compute and another program is called as print. So here the purpose of the compute program is to produce a set of n lines. So it is going to produce a set of n lines for output to be printed by the print routine. So here purpose of compute routine is going to produce a set of n lines, where all those set of n lines needs to be printed on the printer by executing the print routine. So therefore first the compute routine is executed to produce the first line n lines of output. So therefore it is going to produce a n lines of output. So once the n lines of output are ready with the help of the compute routine, so now first set of n lines are ready for printing on the printer. So therefore now the n lines of that is first set of n lines are ready to get printed on the printer. So now in order to print those things on the printer with the help of the printer, so we require to execute the print routine. So therefore, so after execution of the program for first set of n lines, so now print routine needs to be executed. So the print routine is executed to send the first line of a text to the printer. So among total n number of lines, the first line will be transmitted to the printer for getting printed. So that is the purpose of the print routine. So that is, every time whenever a print routine is executed, it is going to send one line of information or one line of text information to the printer. So among the total n number of lines, every time whenever a print routine is executed, it will be sending only one line of text information to the printer. So this is the purpose of the print routine. So now At this point of time, instead of waiting for a line to be printed, the print routine may be temporarily suspended. So here the objective of the print routine, it cannot print all the n lines, so which has been computed by the compute routine. Among n lines, it can print only one line at a time. So during the printer is printing the one line, so during that time print routine becomes that is, there is no job of print routine, so therefore print routine program can be suspended. So and we can resume back the execution of the compute routine. So that is, whenever the printer becomes ready, it alerts the processor by sending an interrupt request signal. So in response, the processor interrupts execution of the compute routine and transfers the control to the print routine. So the print routine sends the second line to the printer and again it is suspended. So then the interrupted compute routine resumes execution at the point of interruption. So now we have two programs. This is program number 1 called as compute routine, and we have program number 2, print routine. So here compute routine objective is to produce a set of n lines. So whereas print routine objective is to send one line among n lines to the printer. So now the printer is an IO device now, so that printer is going to interrupt the main program. So here we will consider, let the compute routine be the main program and print routine might be the ISR. So compute routine program number 1 acts as the main program. Program number 2, print routine, acts as an ISR. So now the printer is an IO device. So whenever the printer becomes ready, then it is going to interrupt the main program. So let us consider compute routine having a set of instructions. Assume that when the compute routine is executing an ith instruction, an interrupt has been occurred. The printer is going to send an interrupt signal to the main program or to the processor indicating that the printer is ready. So that is, it is going to send an interrupt signal. So whenever an interrupt signal is being received by the processor from the printer, then currently running compute routine has to be stopped, so that it is going to give the service for the printer. So printer function has to be started. So in order to start with the printer function, so it has to give the service for the interrupt. So in order to give the service for the interrupt, the currently running program compute routine will be stopped. That is, I+1 instruction address will be saved, which is the program counter content. So now ISR called as print routine will be started with the execution. So now when this print routine when the print routine started its execution, it will be sending a one line of text information to the printer. So once it send the one line of text information to the printer, it has nothing to do with that. So until the printer prints one line of information, one line of text information, it has nothing to do that. So that it can send once that particular print routine execution is over, so the ISR execution program is over, so that a main program can be resumed back. So that is, print routine is going to send one line of text information to the printer, and automatically once that ISR execution is completed, so control is transferred to the main program. So therefore, that is, print routine has nothing to do with the job. So therefore main program, that is compute routine, will be resumed back its execution. So compute routine can generate second set of n lines that has to be printed on the printer. So that is, certain useful task will be running till the printer prints one line of information. So that is, whenever the printer becomes ready, it alerts the processor sending an interrupt request signal. So it is going to send the printer will be sending an interrupt request signal to the processor whenever a processor is executing the compute routine when it is under an ith instruction. So in response, the processor interrupts the execution of the compute routine. So that is, the currently running compute routine will be stopped and transfer is given to the print routine. So print routine now it acts as an ISR. The print routine is going to send the second line of the text information to the printer. So again it is going to get suspended, because the only job of the print routine is to send a line of information. So its job is to just send a line of text information to the printer. So once that line of text information is transmitted to the printer, it has nothing to do. So therefore again the print routine option, the print routine program is going to get suspended, and the main program, that is compute routine program, is resumed back. So that is after again suspended. So then the interrupted compute routine resumes execution at the point of interruption. So this process continues until all n lines have been printed and the print routine ends. So this the execution of compute routine. So during execution of a compute routine, printer will be interrupting the processor, and wherein compute routine is going to call the compute routine program will be stopped, and print routine, which is an ISR, it will be executed. This procedure again after sending the one line of text information to the printer, so resuming back to the main program. So this procedure will be repeatedly running until all n lines have been printed. So the print routine will be restarted whenever the next set of n lines is available for printing. So that same routine will be executed when we have to print the next set of n lines. If the compute routine takes longer time to generate n lines than the time required to print them, the processor will be performing certain useful computation all the time. So this is regarding compute routine and print routine. So whenever a processor receives an interrupt request, it must branch to the ISR, so that is to the interrupt service routine. So it must also inform the device that it has recognized the interrupt request. So now whenever an processor is going to get whenever the processor receives an interrupt request, so one work is to be done is to it should go to the interrupt service routine. So that is, the processor has to execute the ISR. So it is one job. Another job is it should give the intimation to the device, the one which has generated the interrupt request signal. So this can be, that is, intimating the intimating the device that its interrupt request has been recognized. So this can be accomplished in two ways. So here some processor have an explicit interrupt acknowledge signal for this purpose. So whenever any device interrupt the processor by using an interrupt request signal, so that particular device interrupt request, if it is recognized by the processor, so it is going to intimate the requested device with the help of two things. So one is, so it can be intimated by sending an interrupt acknowledgement signal. So if an interrupt acknowledgement signal is transmitted from the processor to an IO device, so it indicates that our interrupt request signal is recognized and it is accepted. So say for example we have a processor and we have a device. So here this IO device, whenever it becomes ready, it sends an interrupt request signal. So once its interrupt request signal has been recognized from this particular IO device, a processor is going to send an acknowledgement that this device has been recognized. So it is done with the help of an interrupt acknowledgement signal. So that is regarding interrupt acknowledge signal. So in other cases, the data transfer that takes place between device and processor can be used to inform the device. So if it does not having an interrupt acknowledgement signal, so during data transfer time, an acknowledgement or the information can be transmitted to the device saying that device is recognized, that interrupt request is recognized. So now treatment of an ISR routine, it is very similar to that of the subroutine. So whatever we call it as an ISR is nothing but it is an interrupt service routine which is consisting of a certain set of instruction. So as soon as an interrupt is generated, received by the processor, a service will be given, that is by executing the ISR. ISR is nothing but here it is a small program now again. So now there is a similarity between interrupt service routine as well as subroutine. So but there are slight differences, there are significant differences. So subroutine performs a task that is required by the calling program. So that is main program is going to call the sub program, so that we call it as a subroutine. But in case of interrupt service routine, so interrupt service routine may not have anything in common with the program it interrupts. So which program is going to get interrupted, that program and ISR program does not have anything in common. That is, there is no proper relationship between the interrupt program as well as interrupt service routine. So interrupt service routine and the program that it interrupts may belong to different user. They are completely, ISR and interrupted program are independent, they are completely different, so may be different. As a result, so before branching to the ISR, so not only the program counter but other information also needs to be saved. So whenever we are moving from main program to sub program, in order to come back to the main program, that is whenever we are executing the subroutine, so when we are executing the subroutine, the calling program and the called program, so calling program is going to call the subroutine. So once a subroutine is executed, it will come back to the main program. So therefore we require a return address for that in order to come back to the main program. So whereas in case of interrupted program and ISR, so as they are completely independent, so not only saving the content of the program counter as in case of subroutine, so here other things also needs to be saved, such as condition, code flags, processor register, all those needs to be stored. So that is, we are supposed to store all this information, not only PC but other information such as condition, code flags and processor register used by both the interrupted program must be stored. So this will enable the interrupted program to resume execution after returning from the ISR. So once the return means, why we need to save condition, code flags and other processor register, because whenever an ISR program is executed, it may modify the content of the condition, code flags as well as few of the processor register. So if these condition, code flags and processor registers are modified, then the main program content things are going to get erased. So therefore condition, code flags and other processor registers along with the program counters needs to be saved somewhere. So therefore once the ISR program is executed, it has to resume back to the main program. So once it resume back to the main program, so without any problem, it can execute the main program. So this will enable the interrupted program to resume execution upon return from the ISR. So here saving and restoring information can be done automatically by the processor or explicitly by program instruction. So I have to save certain, means processor has to save the content of program counter, certain special purpose register contents as well as condition, code flags. So all this saving will be done automatically by the processor, or else it can be done by program instruction. So here we need to save certain information. So saving and restoring registers involve certain data memory transfers. So this may increase the total execution time. So once the interrupt has been occurred, so it has to execute the ISR. So before executing the ISR, it has to save the content of all these registers, that is PC, condition, code flags, processor registers, all these things needs to be saved. So therefore saving as well as executing, so entire total time for execution of entire total time in order to perform all these functions, it is going to increase the total execution time. So saving and restoring register, so it includes certain transfer, thus ultimately it is going to increase the total execution time. So this increase the delay between the time an interrupt request is received and the start of the execution of the ISR. This particular delay is called as an interrupt latency. So interrupt latency is nothing but the time at which the interrupt has generated and at what time the ISR has been started. So this particular in between gap or in between total time delay, so we call that delay as an interrupt latency. So in order to, I want to minimize this interrupt latency, so I have to, as soon as an interrupt is generated, automatically an ISR program has to be started. So execution or giving the service has to be started. So I have to minimize or I have to reduce the interrupt latency. So therefore, in order to reduce the interrupt latency, most processor saves the minimum amount of information. So what is this minimum amount of information? So minimum amount of information includes program counter as well as processor status register. So I want to minimize the interrupt latency. In order to do that, we are going to just save not all the contents of the registers, so or any special purpose register. We will be saving a minimum information. So minimum information includes program counter and processor status register. So suppose I want to save some additional information also. So whenever such additional information has to be saved, so additional information can be saved explicitly by program instruction at the beginning of the ISR and it is restored at the end of the ISR. So conclusion is, we have discussed what is an interrupt. So interrupt signal, interrupt latency as well as subroutine and ISR. So here interrupt is nothing but it is a signal generated by an IO device when the IO device is ready. So it is a signal for the processor. So the processor is going to stop the currently running a program and it is going to give the service for the IO device which has requested. So that is which IO device has sent the interrupt signal to that particular IO device. A service is given. So service is given in the form of an execution of the program, that is ISR program. So here once the interrupt signal has been recognized by the processor, so even it can send an acknowledgement also in the form of an interrupt acknowledgement signal. So interrupt latency is nothing but it is a time delay between, that is at what time the interrupt has been generated and what time the service has been started. So there is a little difference between subroutine and ISR. In case of subroutine, the main program is going to call the subroutine. So the main program and subroutine both are interrelated. So only when we call a subroutine, we will be saving the content of the program counter. Whereas in case of an ISR, not only saving the content of the program counter, along with that some additional register contents also needs to be saved, and there is no relationship between the calling program as well as, that is interrupted program as well as ISR. So these things we have discussed under this lecture. Thank you.